Good morning, all of you. And I'm Jayaraman. I'm going to explain about subtractive rapid prototyping. First of all, we want to know what is rapid prototyping, what is the why it is needed. In today's competitive global market, the designers have to come up with new innovative designs that address both form and function. For this, we want to need of a new technology which is called rapid prototyping. The rapid prototyping become an important part of manufacturing process because prototypes helps to testing prior to production and also helps to pinpoint the possible problems that are occurring due to the design faults. The rapid prototyping is very much helpful because we have to go for a pre-model of a working object which is to be pre-modeled, and it will be having tested with the all the required uh, forces are acting on the body which is are previously initially it is tested using the rapid prototyping model, and it converted it to the original model with a scale ratio. It may be a 1 is to 2 or 1 is to 20, like that. It's a scale down or enlarging scale model. And we are going for rapid prototyping. Prototype is a physical representation of a product. So the prototype is communicating the visual layout of a product. Whenever we go for a new component, whenever we go for a new component which is to be giving the model. So this is the one of the method which is useful, and it is further classified into two types. One is called additive method, and another one is called subtractive method, which is called generally the rapid prototyping is called additive method, and the new technology is adapted here, which is called subtractive rapid prototyping, and we are going to see in the two classification here. The first one is called additive rapid prototyping. A model or prototype is produced by using adding fused or liquefied material layer by layer, and one we are having the layer by layer material adding, and we are got the exact model which is to be uh, rapid prototyped. And here this video shows that there is a base material and the product will be added liquid here and there, and it will be added continuously, and finally we got the model like this method is called additive rapid prototyping. We are adding one the layer liquid layer by layer continuously, and it will be achieved the final component. Finally we have taken the component out from the machine, and we are having some finishing operation on this, and will supply to the component to the required area, and we are going to test the component by using this method. And the next one is called subtractive rapid prototyping, the entirely opposite of the additive rapid prototyping. This model is to be removing the material from the workpiece, and finally we got the component which is to be required or it may be designed. And this is related to the CNC machining operation. This machine is operation is done by some CNC router. It will be high speed compared to the CNC machine, and the operation will be very easy. And this is the subtractive rapid prototyping machining process workflow. And here we want to need design a component which is used by some CAD software like ProE or AutoCAD, like that, and we want to use another software is called Disk Proto, which is to be helpful using this CNC router. It's called this machine is called ISLCPM3020 model, and which is used with the software of Disk Proto. And from this we are converting the coding and all to the machine by using remote win. And here this is the process. ProE or AutoCAD is for model creation, and that file will be transferred into saved as STL format, and it will imported to Disk Proto, and we are having some NC code generation using Disk Proto, and the NC codes are converted send it to the remote win. Remote win is the machining center, and this is the working machine which is to be an experimental working machine. And this is the specification of the machine. The machine is have name called CNC router, and the name is CPM 3020 IESLE rotation axis, 300 rotation axis. It is speed having 11,000 to 25,000 RPM, and motor power is 5 HP. Drive is stepper motor drive. Maximum part size is 300 into 200 into 90 mm, and the table is moving T slot platform. Travel range is in X direction 195 mm and Y direction is 200 mm, and Z, that means that the spindle is moving up to 130 mm height. The table size is 500 to 250 mm. Maximum feed rate is 50 mm per second. The tool shaft diameter is 1 to 8 mm. Color may be used for different sizes. The power required is 220 volt, 50 or 60 hertz.